Compounds which are made up of hydrogen and carbon are called as hydrocarbon. Ritvik, Devanshika. You there, both of you? Devanshika?
Yes, sir.
Ritvik?
Yes, sir.
Okay. You know, na, hydrocarbon, the compound which are made up of hydrogen and carbon are called as hydrocarbon. Okay?
It's in the name.
Yes.
Wow. I'm saying it's in the names. Wow.
Yes. It's the definition in its name only. Okay. So for like alkanes, we have three types of main two types we have for alkanes. First is called saturated hydrocarbon and unsaturated hydrocarbon. Unsaturated hydrocarbon. In saturated hydrocarbon, we have alkanes. And in unsaturated hydrocarbon, we have alkenes and alkynes. Okay. So see here, the general formula for alkanes is CnH2n plus 2. So that formula is called as empirical formula. It's called a empirical formula. Okay, what is empirical formula? The simplest atomic ratio of any compound, okay, is called as the empirical formula. Here that n is equals to number of carbon atom. Here that n represents number of carbon atom. Okay, suppose if you are taking n equals to 1, then CnH2n plus 2 will become, see, we have n equals to 1 here, so we have C1, then H2 into, again we have n here, so here again we have to multiply by 2 plus 2. Now C1 is, we used to represent it by C. H 2 into 2 is 4 and 4 plus, yes, 2 into 2 is 4 and 4 plus 2 is, here n, n is value we have 1, so here we have to keep 1 only, no?
4.
Now yes, 2 1 is 2 and 2 plus 2 is 4. So now we have formula, it is CH4. If suppose we are taking n equals to 2, then our formula CnH2n plus 2 will be C2H2 into 2 plus 2. So it will be C2H. 2 into 2 is 4 and 4 plus 2 is 6. So it will be C2H6. Okay. So see here, we can place value of n equals to 1, 2, 3 up to infinite. We will get each time the saturated hydrocarbon called alkanes. Okay. So that general formula, it is CnH2n plus 2 is the general representation of alkane, which is called as empirical formula. Okay, which is called as empirical formula. Understood what the empirical formula is all about? Okay, so here we have the fourth question on that basis called empirical formula. Okay, the simplest atomic ratio. So see here, the chemical analysis of carbon compound gave the following percentage composition by weight of the element present. Okay, so percentage of carbon is 10.06%. Here we have 10.06%. Then here we have hydrogen percent, and which is 0.84%. The chlorine percentage is 89.10%. Okay, calculate the empirical formula for the compound. Now here we have to derive empirical formula. See here, we have three elements here: carbon, hydrogen and chlorine. Carbon's percentage in given problem is 10.06%, 0.84%, and 89.10%. Their atomic mass is what? Carbon have atomic weight,
12.
beta, it is, yes, 12. For hydrogen it is 1,
Yeah.
and for chlorine it is 35.5. Now we had to divide that percentage by the atomic weight. That will be the atomic ratio. That will be atomic ratio. So what is atomic ratio? Their percentage divided by atomic mass. Okay, so see, that will become 10.06 divided by 2. So it will be 0.84. For hydrogen, 0.84
For
divided by
itself by
1.
1. 0.8
Yes,
for itself.
yes, it will be, yeah, itself. Now we have 89.10 divided by 35. If we will multiply that, we will get 2.51. So see here, now we had to convert that into simple ratio. So in order to convert that in simple ratio form, we had to multiply by 0.84. See here we have frequency of both. Okay, it's maximum, so we have to multiply we have to divide all by 0.84 only. So here we have that 0.84 divided by 0.84, that will be 1. Again here will be 1, and if we will divide 2.51 by 0.84, we will get approximate 3 beta. Okay, that means in the empirical formula of that compound asked here, we have one carbon. Okay, carbon is 1, then hydrogen is also 1, and chlorine is 3. So that will be CHCl3. CHCl3 will be the empirical formula. Okay, see here it is given CHCl3. Okay, so this is the way we have to derive the empirical formula for given questions. Okay, everyone.
Okay,
Yes,
sir.
sir.
Now you have here on 5th question. Okay, a carbon compound on analysis give the following percentage composition. Carbon here we have 14.5. So now I'm using black ink here so that you will understand. No, reading itself. Let me erase that data. Same table we will use for solving the next question. Okay, see, for carbon it is given here 14.5%. So it is 14.5. For hydrogen 1.8%. For chlorine 64.46. 64.46. And for oxygen it is 19.24. So I am increasing here 1 for oxygen, which is 19.24. 19.24. Now the atomic weight here we have for chlorine 35.5, for hydrogen we have 1, for carbon we have 12, and for oxygen we have 16. How much? 16. Now see here we had to divide that 14.5 by 12 here. So I'm calculating here 14.5 divided by 12, that will be 1.8 divided by 1, and it will be 64.46 divided by 35.5, and here that will be 14.24. It is 14.14. No, it for oxygen. No, it is 19.24. It is 19.24. So 19.24 divided by atomic mass of oxygen is 16. So 16. Now we had to calculate all the points. So 14 point, let me start calculator here so that calculation will be fast. Okay, so first we have 19.24. 19.24 divided by 16. So it will be equals to, it will be 1.2. So I'm writing here 1.2 for oxygen. Now for carbon, it will be 14.5 divided by 12 equals to, it is again 1.2, it is 1.2. Then for it will be 1.8 only, 1.8. Now for chlorine we have 64.46 divided by 35.5. It will be 1.8. It will be 1.8. Okay. So we have values here. We calculated, yes, 1.2, 1.8, 1.8, yes. Now we have to divide all by 1.4. The smallest number is 1.2 here. So we have to divide all by 1.2. So what we will get here? So here I'm calculating here 1.2 divided by 1.2. It will be 1. So for that again we will get 1. Now here we have 1.8 divided by 1.2. So it will be 1. So approximate 1.5. Yes, it will be 1.5. So here we have 1.8 divided by 1.2. So it will be 1.5. Here also 1.8 divided by 1.5. No, 1.2. It will be again 1.5. So see again, here we have these two are in simple ratio form, but they are not in their simple ratio. So again we have to multiply both by 2 so that these two will become in simple ratio form. So we have to multiply all by 2 now. So into 2, into 2, into 2, into 2. So for oxygen we will have here 2. For carbon again we have 2. For hydrogen we have 3, and for chlorine we have 3. So I'm writing here ratio for carbon. Oh no, first we will write for oxygen is for 2 atom. For carbon again
So
we have
1
2 atom. No, 2, no, 2 here.
and 1, sir.
No. 2
Next
here.
one.
We have multiplied by 2, no?
No, next one. I'm saying
Yes.
1.5.
So 1.5 into 2, that will be 3. So hydrogen will be 3.
Not
And
divided by 1.5 down. It's separate 1.5.
no, 1.5 we have multiplied it by 2.
Yeah. The down one is another 1.5, sir.
That one?
Yeah. It looks like it is getting divided by 1.5. Is it another one, sir?
No, we have multiplied it by 2. 1.5 into 2 will be 3.
Yeah.
So for chlorine we have 3. Okay. Yes. So here the
And the
formula.
simple ratio means it should have no decimals, right?
Yes. No decimal
Okay.
form. Yeah. So we have to convert first into the simple ratio form. So now here we have the empirical formula. It will be, first we have to write carbon. So it will be C2, then H2, no,
H3.
hydrogen will be 3. Yes.
Yeah, H3,
So it will
Cl3.
be H3,
Cl3.
O2 and Cl3. Yes. Like this. Let's check. Yes. It is
Yeah.
H2, H3, Cl3 and O2. Okay. Here that Cl3 and O2. So this is the empirical formula. So I hope you will are able to calculate next one. Is it?
Yeah. Yes, sir.
Okay. So in sixth problem, here we have one more example. Okay, so now we will calculate the volume for the gases at STP, means standard temperature and pressure. And we know all the gases, okay, all the gases of 1 mole at standard temperature and pressure, they acquires the volume of 22.4 liter. All the gases, all gases, all gases at standard temperature and pressure, 1 mole of any gas acquires 22.4 liter of volume. Okay. So see here, the question says, what volume of carbon dioxide is obtained at STP by heating 4 gram of CaCO3? So here we have 4 gram of CaCO3. CaCO3. It is 4 gram. So I am writing here 4 gram of CaCO3. Okay. So that will be mass. It will be mass. Now we have to calculate molar mass here. See here, if we will heat that calcium carbonate, so what we will get, beta? We will get CaO plus CO2. It is the dissociation reaction. It is the dissociation reaction. Is it or not? So when we will heat that, we will get carbon dioxide here. Carbon dioxide. Is it or not?
Yes, sir.
Yes. So once that means if we are calculating, or we are suppose getting heating 1 mole of calcium carbonate, that means we are getting 1 mole of carbon dioxide. Is it or not? Yes. Do reply. Do reply, everyone. If we are heating 1 mole of calcium carbonate and we are getting 1 mole of carbon dioxide, that means we had to calculate number of moles in calcium carbonate, we will get number of mole of carbon dioxide. Is it or not?
Yeah.
Yes. So first we had to calculate number of mole of calcium carbonate in 4 gram. So we have mass, beta. We have already the mass. Now we have to calculate molar mass. So what is the atomic mass of carbon? No, calcium. It is 40. It is 40.
40. Yeah.
Yes. For carbon, it is 12.
12.
For oxygen, it is 16. But we have 3, so we have to multiply it by 3. So 16 3s are 48.
Yeah.
Plus we have 12. Plus we have 40.
52.
So 48 plus 12 will be 60, and 60 and 40 will be 100. Is it? Yes.
Yes, sir.
So now we have to calculate moles. Moles. So moles will be what? It is mass divided by molar mass.
Molar mass.
Yes. So mass is what? It is 4 gram. And molar mass is what? It is 100 gram. So now we have to calculate 4 divided
0.25. No, 25. 25. No,
Yes.
that's a 0.25.
400,
0.04.
Yes. It will be 0.04. Wait. Let me calculate here. It is not 25, no? 0.04, yes.
0.04, yeah, that's one.
Yes. So we have 4 divided by 100. It will be 0.04. So here we have N equals to 0.04. And now we know that 1 mole of any gas at standard temperature and pressure acquires volume of 22.4 liter. Okay, that means we had to multiply that. Okay, therefore, now we have to multiply that 1 mole of, it is 1 mole. We have to multiply 22.4 to N. Therefore, N into 22.4. So what is N? We have 0.04. So 0.04 into 22.4. Okay. So let multiply 0.04 into 22.4. It will be 0.896. it will be 0.896 and it will be in liter beta. It will be in liter. Okay, so see here again we have calculated, it is 0.896 and our answer is also 0.896. Is it?
Yeah.
Yeah. So this is the way you can calculate the volume of any gases at standard temperature and pressure. And standard temperature is what it is, 25 degrees Celsius or 298. See, here we have 273.15. Just add 25 here. Okay, so it will be 298.15. It is the standard temperature. And pressure is 1 atmospheric pressure. Okay, so at any gas acquires 22.4 liter, okay, of volume of 1 mole of gas at 298.15 Kelvin temperature and 1 atm pressure. Easy? Easy, everyone?
Yeah.
Okay. Now we have to understand disproportion of the reaction. Disproportion of the reaction.
You mean disposition, sir?
Disponent, no, it is disproportion.
Okay.
Yeah. Suppose here we have beta glucose, sugar. Okay, sugar is what it is, C12H22O11. It is O11. O11. I have just added water here. Okay, so that will go disproportion like this. It will form C6H12O6. It is glucose plus C6H12O6. It is fructose. Okay, see, both glucose and fructose have the same molecular formula. They have both like same molecular formula, but functional group is different. Okay, in glucose and fructose. In glucose we have aldehyde group and in fructose we have ketone group as a functional group. Okay, but they have the same molecular formula. So the sugar that we use to eat every day, or like or we are using for the preparation of tea, milk, etc. Okay, the sweets we are using sugar. This is sugar. It contains fructose and glucose. Okay.
Yes, sir.
Yeah. So this reaction we can say this is the disproportion reaction. This is the disproportion reaction. We have one more example for hydrogen peroxide. H2O2. It is hydrogen peroxide. I am just heating that. Okay, and it will form H2O beta, water, and oxygen gas will release from here. So see here, this is hydrogen peroxide. It is hydrogen peroxide and it undergoes disproportion reaction, okay, to form water and oxygen. Water and oxygen. Okay, again, this is the disproportion reaction. Understood?
Yes, sir.
Okay. So here it is, question is given, what is disproportion reaction? Give example. So the redox reaction means those reaction in which oxidation and reduction. Oxidation and reduction reactions take place simultaneously are called a redox reaction. Okay, so the redox reaction in which element undergoes both oxidation and reduction simultaneously are known as disproportionation reaction. Okay, so any chemical reaction in which oxidation and reduction undergoes simultaneously are called as disproportion reaction. Okay, everyone?
Yes, sir.
Yes. Okay, assign the oxidation number to the underlying element. Okay, so for that I will like make you understand the simple trick by which you can assign the charges. Okay, you can assign the charges. Okay, so first we will use H2SO4. H2 H2S2O7. Wait a second, beta. I'm again getting call from one of the student. What is time now? It is 7, no?
Yes, sir.
But they're calling like before time. Wait a second. To the given species. See, underline is given on sulfur here. That means we had to calculate oxidation state of sulfur here. Okay. So do always remember, you know oxygen. Everyone, keep reply.
Yeah.
Oxygen. What is atomic number of oxygen?
14. No, 16.
Huh?
16.
No, atomic mass, beta, it is
8,
16.
sir.
8. Atomic number is 8. Its electronic configuration is 2 and 6, right?
Yeah.
Octet rule says every atom must have 8 electrons in their outermost shell. But in case of oxygen, we have only 6 electrons in outermost shell. So oxygen requires 2 more electrons in order to acquire stability. Is it or not? Is it?
Yes,
Yes, sir.
That means oxygen will acquire 2 minus charge. Is it?
Yeah.
Yes. So the charge on oxygen is what? It is -2. But here we have 7 oxygen. So we have to see that -2 charge is on 1 oxygen. So how much charge on 7? So we have to multiply it by 7. So 7 into 2 will be -14. Is it? Everyone, keep replying quickly. One
Yes,
oxygen
sir.
atom
And
have
answer will be 1.
-2, so 7 will have -14 charge. Yes. Hydrogen have beta +1 charge. But here we have 2 hydrogen, so we have to multiply it by 2.
2
So
hydrogen
total charge
plus
we
2.
have 2. Yes, +2. Now we have to compare that +2 and -14. If we will compare that, we will have -12 charge remaining.
Yeah.
Is it? So that compound is given here, it is neutral because there is no charge is given over here. That means it is neutral. Okay, that means it is neutral. That means we had to neutralize that -12 charge in order to make compound neutral. Is it? So in order to make that -12 0, we had to add +12 here. That is going to be 0 then. Is it?
Yes, sir.
That means that +12 charge will be for 2s, 2 sulfur here. See, here we have 2 sulfur. That means that +12 charge is responsible for 2 sulfur atom here. That means we have to multiply that 12 or divide that 12 by 2. So we will get beta +6. Is it? We will get here +6. That means one sulfur will have +6 charge and other will also have +6 charge. That means the charge or the oxidation state of sulfur is +6. Okay, +6. Understood?
Yeah.
Yes. So first we have calculated now. Now for F, NaBH4. NaBH4. Who is going to tell me what is going to be charge on boron? See, do always remember here again we have NaBH4. So we know charge on sodium is always 1. That see, if hydrogen is present in that side, okay, in extreme right side, it is extreme right side. So the charge on hydrogen will be -1 beta. If hydrogen is present in extreme left side, then it will be positive charge. Okay, see here. Here we have hydrogen. It is on that extreme right hand side. Is it or not? Keep replying.
Yes.
So here you have to just keep in mind, if hydrogen atom is present in right hand side, then charge will be positive. And if it present in extreme left hand side here, left hand side, so the charge will be negative beta. Very important, that 2 point you have to remember all the time, always. Okay, whenever you will like have chemistry as a main subject or the sub subject also, minor major, so you have to like remember all these things I'm teaching here. Okay, so hydrogen, if it is present in extreme left hand side, so it acquires negative charge, and if it is present in extreme right hand side, then it acquires positive charge. So for that hydrogen we have -1 charge, so we have 4 hydrogens, so we have to multiply by 4. Now we have -4 here. Now again we have to compare +1 and -4. What we will have? -3. So boron, here that boron will have +3 charge. Okay.
Yeah.
Yes, +3 charge will be on boron. So let's check whether boron is having +3 charge or not. Boron, see here, this is a +3 charge. For here sulfur we have +6 charge. Once you will like understand that technique, you will solve very quickly. Okay. Okay, everyone.
Yes, sir.
Okay, for next, here, see that calcium will always have beta valency 2, and it is metal, so it will have +2 always. Okay, +2. And here we had 2 oxygen, so one oxygen will acquire -1 charge. Other will also have -1 charge. Then -1 will be -2, and -2 and +2 will be 0, neutral. Okay, so the charge on oxygen will be -1. Now for KMnO4 we have to calculate that. Very example, K2MnO4. So again mass of, oh no, not mass, the charge on oxygen is -2. We have 4 oxygens, we have to multiply by 4. Now we have -8. Potassium is metal, so it has charge 1. Okay, we have 2 potassiums, are multiplying by 2, so we will get +2. Now we have to compare -2 and +2 and -8. So we will have how much? -6 charge. That means that Mn will acquire +6 charge. Understood?
Yes, sir.
Yes. So here on Mn, okay, we have charge +6. Yeah, like this. So like this you can assign charge for NaH2PO4, here also NaHSO4. Okay, so just solve and let me know. Phosphorus oxidation state here, and sulfurs over here, and phosphorus over here. Just calculate. I'm waiting here for your response. What is charge on phosphorus? You have to tell here. Here for sulfur and here for phosphorus. Yes, let me just solve, everyone. Yes, Ritvik, Devanshika, Shehar, Niyati.
Sir.
Yes, you have to calculate oxidation state of phosphorus on A, sulfur on B, and phosphorus on C. Okay, just let me know, beta. Quick. Are you calculating, everyone? Ritvik?
Yes, sir. Calculate.
Okay.